Producing things like plastics, fuels, and medication requires chemical processes. But these chemical processes demand a lot of energy and generate a lot of waste. What if I told you that we can look to nature to help us improve these chemical processes to make them more efficient? In the past decade, chemical processes have already improved a lot. In Flanders, we have already achieved an efficiency gain of 10%. But further improvement becomes increasingly expensive and more difficult on a technical level. At the root of this challenge is catalysis. Catalysts are chemical additives that we use to support chemical reactions. But currently used catalysts don't actually work very well, resulting in energy-intensive and waste-producing processes. Nature has the answer. Enzymes are the catalysts used by living cells, and they support most of the chemical reactions going on in there. And they do so at room temperature without producing any waste. Wouldn't it be great if we could use them in our own chemical processes? Unfortunately, enzymes are fragile, and they rely on the back office of the living cell to do their job well. But what tiny cells can do, for sure, well-trained chemists can do much better. During my research, we improve catalysts by taking concepts from enzymes and building them into our own catalysts. We can, for example, take reactive pieces from enzymes and build them into sturdy crystals called zeolites. This then makes them reactive at room temperature and sturdy as a rock. And look, it actually works. To reduce waste, we use another property of the zeolite that only becomes visible when we zoom in about 100 million times. Very small holes in the zeolite allow us to selectively turn the right reagents into the right products. So harnessing the fundamental concepts of enzymes and building them into sturdy industrial-scale zeolites will allow us to improve chemical processes, and by doing that also our standard of living and our environment.